All right, welcome. MAP4C day 65. The 3-minute review today is review of yesterday's stuff, last day's stuff. Ferd wants to have $1,800 saved up for a trip to lovely Cancun, and there's lovely Cancun. There's Ferd. Let's put Ferd on the beach. There he is. Ferd. In 3 years' time, if he can earn 6% a year compounded monthly, how much should he invest now? So this idea is he's going to invest some money now, and it's going to grow to $1,800 in 3 years. So that gives us a hint about what we need to find in our formula, right? A, P, I, and N. The amount at the end is $1,800, and we don't know how much he needs to invest now. The interest rate is 6% a year, written as a decimal, 0.06 divided by 12 because it's monthly. Gives me the I there. N is 3 years time, 12 months, 36 compound interest periods altogether. Yesterday we rearranged this formula into what some people call the present value formula, and so if you wrote that one down instead, good, fine and dandy, you could have done that. I'm going to do it the other way, which was to substitute in and solve. All right, we got 1.005 to the exponent 36 here, and then I could actually do that calculation and get the value, or I can divide both sides by that, right, and get 1,800 over 1.005 to the exponent 36. However you like to do these, there's lots of ways. And then I get how much Ferd has to invest right now, which is, what, $1,500. So Ferd would invest $1,500 now. Dandy, and that's what we did yesterday. Before we go on with today's stuff, I want to mention about how this is a pretty stupid question, because I mean, 3 years from now, he wants $1,800. It means he'd have to have that much now, right? Well, why wouldn't he just take the $1,500 now and go someplace cheaper, right? Why wouldn't he take that? Doesn't make any sense that he would invest it. I think he'd go and take the vacation right now for $1,500. Or maybe he doesn't have the $1,500. What might make sense is for him to invest a little bit every month, right? That's how we save. You know, 36 in 36 months, that would be, maybe he'd have to put away, you know, $50 a month or something like that in order to have the $1,800 saved up. Right? That's what we'd want to do, and the interest would be on top of that. This idea of investing a bit every month is not only wise investment, and you've probably heard people say about invest early, that business, that bit. This is what today's lesson is about, and it's what this whole chapter is about. So let's get at it. This is what an annuity is talking about. An annuity is a series of regular, we talk about equal payments or investments. In a way, when you have your car payment's $350 a month or whatever, well, that's an annuity because it's a series of regular and equal payments. Okay, well, how would Ferd's investing change then? Well, here we go. Ferd invests $300 every 6 months at 8% compounded semi-annually. How much will he have at the end of 3 years? Well, notice this is weird. I can't use this formula because, you know, I don't know what this is. It's 300 for the first 6 months, but then after 6 months he puts another $300 and this is 600. So this formula doesn't work at all. But if we break it into pieces, we can use the simple interest formula, and that's how we're going to get started. Notice for 3 years, he's making investments every 6 months. That means there's 6 payments, right? There's going to be 6 payments altogether. At the start of the first one, while he hasn't earned, there's nothing in the bank account before the first investment. The interest, we're going to use the simple interest formula, okay? Simple interest formula where the interest rate he's earning is 8% a year, and for the time, this little period is 6 months, right? So that's half a year. And in fact, I can use a simple interest formula to calculate how much interest he gets. Well, the principal is, well, for this first one, there's nothing in there, so he earns 0, but he deposits $300, and at the end of the 6 months, he's got $300. See, now that $300 starts earning interest, right? So $300 at 8% interest. You say, well, hang on, it's compounded. Well, I'll talk about that in a second. Times 0.5, 0.5 years, right? That's 0.5 years. And then I get that's $12 interest, right? But then along with the $12 interest that he earned over those 6 months, he's going to put in another $300. So now how much has he got at the end? He's got 300 plus 12 plus 300. He's got $612 in the account now, right? And that at the beginning of the next year, he's got $612 in the account, and it starts earning interest. And you say, well, why are we using the simple interest formula? Isn't it compound? Well, this is the idea of compounding interest, is that now I'm going to earn interest on that $12, right? So because it's $612 in the bank now, this becomes the new principal, right? How much interest does he earn on that? Well, he earns, principal is $612, 8% a year for half a year is $24.48. But he puts another $300 in. And you see how this is adding up very quickly. I add those 3 things up, amount that he started, plus the interest he earned, plus the $300 payment. He's got $936.48 in the bank. And this keeps going. I'm only going to do a couple more like this and then show you the final answers. So here, then this is the new amount that earns interest, and I'm going to earn interest on interest. That's the compounding part, and that's 37.46, and so on, and I can keep going. In fact, instead of watching me write all these numbers out, I've actually got the answer here on the next page. Okay, so you see there's the complete table, and you can pause the video and copy that out. You should be following along with these calculations. Make sure you can do it. All right. Also notice that this is how much he's got in the account at the end. That's pretty good. So therefore he has $1,989.90 at the end of the 3 years. So, well, hang on. I thought it was 6 years. No, those are 6 payments. Remember, they were semi-annually, so 1 year, 2 year, 3 years at the end of the 3 years. Also notice that how much interest has he earned? Well, in this table, all I would have to do is add up this column. So he earned, add up this column, $189.90 in interest. Now also note that if I wanted to figure out how much interest is, this is how much he's got at the end. At the end he had $19.89.90, but quite a lot of that was his payments, right? He made 6 payments. So I could subtract off the 6 payments that he made to figure out how much interest he actually earned, right? And that's the same $189.90. Check that out. So this is going to be a nice thing, this little calculation, to be able to do instead of having a big long column. Because think about this. Imagine if he was investing every month for 3 years. If it was every month for 3 years, this table would have every month times 3 years, it would have 36 rows. And we'd have to go through this calculation 36 times. And you can see it gets pretty tedious. Imagine this one, right? Monthly for 3 years, 36 payments. Let alone when we start talking about house payments. House payments might be for 25 years you have a mortgage, and that's a long, big table. Well, luckily there's another way, and it has to do with this formula. Okay, and it's a nasty formula, I realize, but we'll see that it's not so bad. How am I doing for time here? I'm going to pause there, and we'll pick it up in part 2, folks.